Hello everyone, my name is Madhvi. I am currently studying BTech in JNTU College of Engineering in the Department of Computer Science of Engineering. As a part of assignment, now I am here to discuss about the topic linked list. First, let us know what is meant by linked list. A linked list is linear collection of nodes. The key here is that every node will have two parts. The first part contains the information or data part, and the second part contains the link or address of the next node. Here is the visual representation, how we represent a node. Now coming to the representation of the linked list. We use self-referential structure to represent the linked list here as it follows. Next, coming to the operations that we perform in linked list, we perform the operation insert friend, insert rare, delete friend, delete rare and display operations, and we can search the nodes. Coming to insert friend. A new node can be inserted at front of the previous nodes. A node can store the address of first node in the link of the new node, and new node becomes the first node. If the list is empty, then the new node is the first node itself. As we know that the linked list have nodes, the node have two parts. The first part it contains data, and second part it contains the address of the next node. If first we check whether the list is empty or not. If the list is empty, then the newly inserted node becomes the first node. To check whether the list is empty, we use head equals to null. Here the head always points to the first node. If the list is not empty, then we store the address of the new node to the first node. Next, now the first node becomes the second node and the newly inserted node becomes the first node. Next, here comes to the example. Firstly, we need to insert the node 10. Initially, the list is empty, so the 10 becomes the first node. Now, we need to insert the node 20. We store the address of 10 in the link part of 20. Then 20 becomes the first node and 10 becomes the next node. Now, we need to insert the node 30. We store the address of 20 in link part of 30. Now, 30 is inserted before 20. Next, coming to insertion rare. Insertion rare means we insert the node at the end of the linked list. First, we need to know what is the last node of the linked list. So, we traverse the last node and find the last node. If the list is empty, the newly inserted node becomes the first node. If the list is not empty, then the link part of last node stores the address of the new node. Initially, first we need to create a new node for insertion. Now, we need to check whether the list is empty or not. If the list is empty, then the newly inserted node becomes the first node. If the list is not empty, now to find the last node, we define a pointer temp, which is initially initialized with head node. Keep moving the temp to its next node until it reaches to the last node in the list. Now, we find the last node. Now store the temp of link equals to new node. If the list is empty, the new node is first node and link part contains null value initially. Initially we have 10, so the list is empty. So 10 becomes the first node. Now we need to insert 20. We are performing rare operations, so 20 is to be inserted after 10. So we store the address of 20 in 10. Here the first node of link stores the address of the new node. New node of link contains the null value. It stores the rare element. Now we are going to insert the new node into the rare of the list. Now we need to insert 30. So first, initially we initialize temp equals to first. Now the temp is not equals to null, so it moves to the next node. Now temp becomes 20. Now it is null, so we make temp of link equals to new node. Now 30 is inserted after 20. Now coming to the deletion operations, we perform two operations, delete friend, delete rare. So coming to the delete at friend, we can delete first node of the list by using memory allocation function free. Then the next node will become the first node. If the list doesn't contain any node, it means that list is empty. First, we need to check whether the list is empty or not. If the list is empty, then display list is empty, deletion is not possible and terminate the function. Now, if the list is not empty, we need to set a pointer temp and initialize it with head. Now, set temp of link equals to null. if temp of link equals to null, the second node becomes the first node, and now we can free temp. Now the first node will be deleted. Here is the operation that we need to perform. Initially we initialize temp equals to first, then first equals to temp of link, then we free the temp value. Now the first node is deleted. That here according to example 30 is deleted, and now 20 becomes the first node. Coming to deleting from end of the list, we can use the following steps to delete a node from the end of the single linked list. First, we need to check whether the list is empty or not. If the list is empty, the list empty. Deletion is not possible and we terminate the function. Now, if the list is not empty, as we need to delete the last node, we assign a temp such that we move the temp variable up to temp of link not equals to null, such that we know the last node. So we assign previous node such that previous equals to temp. The previous node points the last before node. So at last when we find the last node, we make previous of null, previous of link part equals to null, and we can delete the node. Now here is an example program that how we can perform the operations of insertion and deletion in linked list. Thank you for listening. Please like, share and subscribe. ఎట్లొచ్చిందో చూడాలి.